The next law that we're going to discuss is Boyle's law. Boyle's law describes the relationship between pressure and volume. And just like in Charles' law, where we had to hold a few different things constant, we're going to have to hold temperature and amount of gas are constant. And let's look at what this relationship is. In this simulation, let's watch what happens when we change the volume of the gas by looking at this pressure gauge. And we're going to hold temperature and amount of gas constant. So as we decrease the volume gets smaller. We notice that the pressure goes up. And this is because in a smaller container, the particles have to travel less distance to bounce into the walls of the container, and the more collisions there are, the higher the pressure. When we increase the volume of the container, the particles now have to travel farther to hit the sides of the container, and the pressure goes down. There's less collisions. So we'll look at it again. As the size of the container decreases, the volume decreases, pressure goes up as we have more collisions, more force against the sides of the container. And as we increase the volume, there are fewer collisions with the sides of the container, so the pressure goes down. To summarize this relationship, as pressure goes up, volume goes down. And as volume goes down, pressure goes up. And if pressure goes down, then volume goes up. So volume goes up, pressure must go down. This is an inverse relationship. In an inverse relationship, one variable does the opposite of the other. Meaning, if one goes up, the other goes down. Just like in Charles' law, we have an equation for Boyle's law. This equation is P1 V1 equals P2 V2, where pressure must be in atmospheres and volume must be in liters. Let's look at a sample problem. So a gas has a pressure of 4 atmospheres and a volume of 340 milliliters. If the pressure is decreased to 2.5 atmospheres, what is the new volume of the gas? So the first thing I'm going to do is circle my variables. What's important? Well, I have 4 atmospheres, I have 340 milliliters, and I have 2.5 atmospheres. I'm also going to underline the question. What am I looking for? I'm looking for a volume of the gas. So I know I have pressure and volume, so that means I need to use this equation, pressure and volume. And I'm going to write a list of variables. I have a P1, I have a V1, I have a P2, and I have a V2. If I call 4 atmospheres P1, that means I must call its volume, 340 milliliters, V1, because this pressure goes with this volume. That means that P2 must be 2.5 atmospheres, and V2 is the volume that I'm looking for. Now we have to check units. ATM is fine, but we need this in liters, so we'll convert that to liters, which would be 0.340 liters. And now we can solve the problem. We'll plug 4 for P1, 0.340 for V1 equals 2.5 times V2. Solve for V2, and you get 0.544 liters, or 544 milliliters.